Okay, as you can see here are all the cofunction identities. So sine and cosine kind of go hand in hand, tangent and cotangent go hand in hand, and secant and cosecant basically go hand in hand. These are derived from a right triangle where basically we know that our two remaining angles besides the right angle have to add up to 90 degrees or pi over 2. Based on all the angles in a triangle always have to add up to 180 degrees or pi. So with that in mind, you can kind of set up these cofunction identities based on which angle you want to be focused on. But if we kind of think about, if I look at theta and I wanted to label some things, we can say this is the adjacent side, this is the opposite side, and this is the hypotenuse. So that's based on theta being the primary focus here. But if we wanted to change our focus here to this other angle at the top, you could calculate that angle pretty easily by saying, well, it's pi over 2 minus whatever this angle is that's given to us. Or, that's the same thing as 90 degrees minus whatever angle was given to us. But what happens in that situation is you're going to be labeling these sides differently. All right, so if you want to say sine of theta, that's going to be opposite over hypotenuse. So this side length over here over the hypotenuse. However, if you focus over on this other angle, that's going to be the adjacent side for this angle over the hypotenuse would be the same ratio. So that would be cosine is adjacent over hypotenuse. So it just is a matter of which angle you want to be focused on. Let's next go ahead and prove this cofunction identity that cosine of pi over 2 minus u is always equal to sine of u. And to do so, what we're going to do is use one of our sum or difference identities for trigonometric functions. So I've written it out here. You can see we have cosine of alpha minus beta is equal to what we have on the right-hand side. So we're going to kind of label these as we've got alpha, we've got beta. So I can rewrite the right-hand side as cosine of pi over 2 times cosine of u, just kind of filling in as we go, plus sine of pi over 2 multiplied by sine of u. All right, so I just filled in the information that was given to us into our formula, the difference identity or difference formula for cosine. And from here, let's see if we can evaluate some of these, like cosine of pi over 2 and sine of pi over 2. Pi over 2 is a nice angle, so we should be able to evaluate that. So it is a quadrantal angle. What I like to do when I'm thinking about quadrantal angles, pi over 2 is going to be up here, is that ordered pair on the unit circle is going to be 0 left to right and up 1. From there, it's important to remember that when we're looking at terminal points on the unit circle, it always goes as our cosine function comes first. So cosine of whatever the value is, comma, sine of whatever the angle is plugged in here. So cosine goes as the x value and sine goes as the y value. So when we're trying to evaluate cosine of pi over 2 plugged in, cosine is going to be this x value. So we can replace cosine of pi over 2 with 0 multiplied by cosine of u plus sine of pi over 2 is going to be the y value for this terminal point. So it's going to be 1 multiplied by sine of u. Well, we know that 0 multiplied by anything is still going to be 0 plus 1 times sine over u, sure enough, is sine over u. Well, that'll simplify to just sine over u. So that's a nice little proof using one of our difference formulas or difference identities for cosine to show that this cofunction identity actually does hold true. So if this helps out, good luck.